Lesson 8.5. We're going to start by reviewing a couple of things that we started to talk about at the end of the hour yesterday. Very quick, but just to bring everybody up to speed on some key parts. We talked about two lines being parallel. And when they're parallel, by definition, it means they will not intersect. And the results of that relationship are as follows. You have a choice to make. Is there a solution or is there no solution? And by solution and no solution, we're talking about an intersection point. So when they say, is there a solution, then they're asking really, is there an intersection? Well, obviously, if you look at two parallel lines, you'll notice they are not going to intersect. So parallel lines have no solution. Then you ask yourself, well, do they have the same slope or not? We talked about this yesterday, and that is that if you have slope being rise over run, it's a constant rate of change. And if another line has the same slope, in other words, same rise over run, they will never cross. They'll always stay the same distance away from each other. So if it's parallel, they have no solution, and the slopes are the same. An example of that would be right here. Notice that we have the same slope for each one. That tells us that they are parallel and do not intersect. But a key part that we mentioned yesterday is they also have to have different y-intercepts. They can be parallel, but they have to have different y-intercepts. If they have the same slope and the same y-intercept, then you would have the same line being drawn over itself, which means in that case you would have an infinite number of solutions. So an infinite number of intersection points. So with that said, if we have two lines that actually have an intersection, then we have a solution. And if they have a solution, then that means their slopes must have been different. In other words, not the same. Otherwise, they would have been parallel. Some examples there. Notice different slopes, different rate of change guarantees an intersection at some point or another. Even if it doesn't intersect on your graph might be too small. So keep that in mind. If you graph two lines and they don't intersect on your paper, if you look closely at the slopes, okay, and here's the end of your graph, you say, oh, they don't intersect. But if you looked at their slopes, you'd see that if you were to extend beyond the graph, they would actually intersect. So even if they don't intersect on your graph, be aware that your graph might be too small. So look at it closely, look at their slopes, and notice if they're the same slope or not. If they are different slopes, they will intersect at one point or another eventually. Now here are some examples that you need to look at and decide, parallel or not parallel. For parallel, we will do this symbol. Not parallel, we'll just go like this and cross it out. So to decide parallel, we look at slopes. Different slopes mean they are not parallel. Same slopes, parallel. -1/2, -2. Different slopes, not parallel. 2/3 and 2/3, same slope, parallel. 0.4 and 4. They're close, but they are not the same. Therefore, they are not parallel. -2.5 and 0.5. not the same, therefore not parallel. Now I'm going to take one of these questions that you have on your homework and your worksheets and take it all the way through. And that means, first question is, are they going to intersect? Well, different slopes, so yes, they are going to intersect. Now if you graph these two, you have -2 intercept. This is this one right here. 1/1 slope, so up 1/1. That's going to be your line. Next one, you have 5 intercept, -2/1 slope. So down 2 to the right 1. And the graph is an approximation, so we would approximate their solution. And my graph could be off a little bit, so let's approximate it and say the solution is the coordinate 2, 0. Now in your assignment it says, check by substitution. Okay, there's two ways we can do that. One is we can plug this in for x and this in for y and c. What I'm going to talk to you about is solving by substitution. And I'd like you to try it. And to solve by substitution, I mean notice that y equals x minus 2. So I'm going to take that and replace the y in the second equation with x minus 2. And I get this statement. Now what I'd like you to do is solve for x. Now to do that, I need to combine like terms. So if I add 2x to both sides, these are like terms right here, so I will get 3x minus 2 equals 5. I add 2 to both sides to combine those like terms. I get 7. Divide by 3, and x equals 7/3. Now, if we do the decimal version of that, that is 2 1/3. Let's look at our picture. The x is 2 1/3. So we approximated it to 2, but this is actually the intersection point, which looks a little bit past 2, so that could very well be the answer. Now to find the y, I'd take that answer and put it right there, which means I'd have y equals 2 1/3 minus 2. Well, 2 1/3 minus 2 is 1/3. So by substitution, we found that the x is 2 1/3 and the y is 1/3. And if you look at that, it is a little bit above the x-axis, so that looks like that could very well be the coordinate. Again, we approximated, and that's what graphing does. It's an approximate answer. But solving through substitution is considered an exact answer. So in your assignment, when we say check by substitution, this is what one method that they mean. And this ends lesson 8.5, and in the next lesson we will pick up on 8.6.